Okay, so that green almost works. So today, 6-5C is going to go on page 80. So if you want to write down page 80, you can glue that in later. It's identifying the asymptotes of the rational functions. So in the past, in Unit 6, we've talked about rational functions quite a bit, and we've talked about this. What is this shape? This is kind of like the parent function, just a sketch. Not a parabola. A hyperbola, right? A hyperbola. And so for the hyperbola, let me get my highlighter here, there's actually two asymptotes. There's one that is horizontal. Where is that? It's along the x-axis. It has an equation of y equals y equals 0, right? Y equals 0. And then it has a vertical asymptote right there, correct? So that vertical asymptote has an equation of x equals 0, yes. So today what we're going to be doing is finding the vertical and horizontal asymptotes, or something called a slant asymptote, which might happen. What does slant make you think of? Yeah, like a dash, like diagonally, right? Some kind of diagonal, not vertical, not horizontal, somewhere in between. So in order to find vertical asymptotes, the first thing you want to do is set the domain equal to what? 0. You can fill that in. Set the domain equal to 0. Blank if possible. What goes here? Factor, yeah. Factor if possible, and solve for x. Good. This should all be familiar because it's the same steps for when you are finding a what? Even before that. Same steps for when you are finding the domain, right? When you are finding the domain and the x values that you couldn't have, those x values that you can't have them because there's a vertical asymptote. So I'm going to go to a problem. I'm going to try to find the vertical asymptote of number 1. By the way, VA stands for vertical asymptote and HA stands for horizontal asymptote. So for number 1, I need to set the what? The denominator equal to 0, because I'm trying to find the vertical asymptote. So I'm going to set x plus 2 equal to 0. Is there any factoring that can be done? No, it's already linear. And then I need to solve, so I need to subtract 2. I get an x value of -2. So my vertical asymptote is the line x equals -2. And if you were doing this process to try and find the domain, you would say, okay, well, the domain is all what? All real numbers except x cannot equal -2. Why can x not equal -2? Because there's a, what did we just find? A vertical asymptote there. Yeah. So we've got a vertical asymptote there that the hyperbola gets very, very close to, but it cannot cross. So that's the vertical asymptote. Can I get a show of thumbs how this seems? Is this okay, not okay? Somewhere in the middle? Somewhere in the middle. Up to in the middle. Okay. All right. So going back, we're going to talk about horizontal asymptotes. There are certain cases where something happens and certain cases where something else happens for horizontal asymptotes. So to find the horizontal asymptote of a rational function, if the degree, wait a second, what is a degree? What's a degree? Yeah, it's specifically what exponent? It's the biggest exponent in a function. The biggest exponent. That's the degree of the function. For example, if I write a function f of x equals x cubed minus 7, well, what is the degree of that function? What's the exponent? 3. So this is a function of degree 3. So when we talk about degrees, we're talking about the biggest exponent. Does that make sense? Okay. So if the degree, or the biggest exponent of the denominator, is greater than the degree of the numerator, then y equals 0 is the horizontal asymptote, just like in the parent function. So off to the side, I'm going to give you kind of a little mini, not picture, but mini function to help you remember. So if the degree of the denominator is greater, so we've got a rational function, x on top, x on bottom. The degree of the denominator is greater, so you've got a big exponent here and a small exponent here. That would be a situation that gives you y equals 0 for the horizontal asymptote. Okay. Can you give me an example of that? Maybe x over x squared. Sounds great. Yes. The next situation is if the degree, or the biggest exponent, of the numerator is greater than the degree of the denominator, so it's kind of flip-flopped, then there is no horizontal asymptote. There's not one at all. So this situation would look like a numerator with a bigger exponent and a denominator with a smaller exponent. That would give no horizontal asymptote. Can you give me an example of what that might look like? X what? X squared over x? Agreed. That would have no horizontal asymptote because the bigger degree is on the top, is in the numerator. And then finally, if the degree of the numerator is equal to the degree of the denominator, then you have a different situation. The horizontal asymptote is the ratio of the highest power coefficients. So let's break down that last piece of the sentence. Ratio is the root word of rational. What does rational mean? Fraction. So what does ratio mean? Fraction. Yeah. So it's the ratio or the fraction of the highest power coefficients. What's a coefficient? The number beside the variable good. So what is the coefficient in 2x to the power of 4? 2. So you take the ratio of those coefficients. So you've got three different situations here for the horizontal asymptote. Either the degree is bigger on the bottom, bigger on the top, or it's equal on the bottom and the top. And each of those situations gives a different horizontal asymptote or no asymptote at all. So let's go to number 1 again. And I want to figure out the horizontal asymptote, so I look at the what? I'm comparing the exponents, the degrees, right? So what's the exponent for x? What? 1. What's the exponent for this, x? 1. So what do you notice about the degrees? They are what? The same. Those powers are equal. Powers are equal. So would that be case 1? No. Case 2? No. Case 3. Because the degree of the numerator is equal to the degree of the denominator. So in order to create that horizontal asymptote, I need to create a ratio with the coefficients, right? So what is my coefficient for the numerator's x value? 1. And the coefficient here? 1. So my horizontal asymptote, HA, is equal to the ratio of 1 over 1, which simplifies to, yeah. So my horizontal asymptote is y equals 1. Yeah. So this is not hard, but knowing what situation is the harder part. So you really have to memorize what happens in each situation. That's the tougher part for the notes today, is knowing when to do what, which means that before a test, you're going to have to study. Maybe some flashcards, some way to memorize what situation makes certain things happen. So the last thing that we need to talk about for asymptotes is we need to talk about a slant asymptote, so something that might be a diagonal asymptote. Slant asymptotes only happen when the degree of the numerator, the top, is exactly 1 more than the degree of the denominator. So you might have x to the power of n on the, n plus 1 on the top, and x to the power of n on the bottom. So whatever the top is, it's got 1 higher power than the bottom's power. So what might be an example? X to the power of 4 over what? X to the power of 3. So do you see how the numerator's exponent, the degree is 1 more than the denominator? So this would cause a slant asymptote. And to find a slant asymptote, you actually have to do the division that's in the function. Most of the time that is a long division. And you typically ignore any remainder that you might get when you do that division. So if I go back to number 1, remember that a slant asymptote only happens when the degree of the numerator is 1 more than that of the denominator. Well, what did we decide about these two? They're equal. So do I have a slant asymptote here? No. I don't. In fact, in order for me to have a slant asymptote, doesn't the numerator's degree have to be bigger than the denominator's degree? So that only happens when this situation is happening, right? So what's the horizontal asymptote? There is none. So you can only have a slant asymptote when there's no horizontal asymptote. Okay, so that's kind of a good thing to know. You can't have both. So let's go on to number 2. Number 2, before we do anything, I'd like for you to factor the numerator and the denominator, because you never know if you might have a hole. Okay, so this is the factored form of number 2. We decided that there are no holes here because there's no common factors you can cancel out, but I can go ahead and take my factored denominator and set it equal to what? 0. Set it equal to 0. Go ahead and calculate your vertical asymptotes. How many are there? 2. Okay, so the first factor here gives a vertical asymptote of x equals what? Yeah, and then the other one? X equals positive 2. So there's my 2 vertical asymptotes. Oh, good. The question was, can you do it the other way where you put the plus or minus? In the domain, that's fine. But here, since we're talking about asymptotes, we're talking about 2 separate vertical asymptotes. So I really do want 2 separate equations, because these aren't just marking places where the domain is undefined. These are marking actual lines. So I do want them separate. No plus or minus here. That was a good question. So when I look at horizontal asymptotes, what do I need to compare in the numerator and the denominator? The degrees. Good vocabulary. What's the degree of the numerator and the denominator? So both are 2. That means that the degrees are equal. So powers are equal, which means what? There's no slant asymptote because I don't have a bigger power on the top. So I can go ahead and put none for the slant asymptote. That's good. And for the horizontal asymptote, since my powers are equal, my degrees are equal, I go by the what? The coefficients. So the horizontal asymptote has a what in the numerator? A 2, that's the coefficient. And then the denominator? What? 1. There's an invisible 1 right there. So the horizontal asymptote is at y equals 2. We'll do number 5. So number 4, in summary, we've got a horizontal asymptote because the powers are equal. And so the coefficients are 1 and 1. Horizontal asymptote is y equals 1. The vertical asymptote comes from setting x minus 1 equal to 0. So x equals 1. And then we talked about the slant asymptote. There is not one because you had a horizontal asymptote. So just in summary, that's number 4 in a nutshell. So now I want you to move back, actually, to number, there we go, number 3. I want you to move back to number 3 because I want to do this one together. First of all, can you factor the numerator or the denominator? No, even though the top is a binomial, there's no greatest common factor you can take out. So, I mean, I guess you could do, you can do sum of cubes, right? This is sum of cubes. You do sum of cubes. Is there? There's a slant asymptote, yeah. Oh, okay, all right. So I'm gonna start with the vertical asymptote because that's the part that we really want to start with, right? Because it's a little bit easier. So what do I do to find the vertical asymptote? Set the denominator equal to 0. And in order to solve for x, I would have to undo the square by square rooting. Thank you. So if I square root both sides, I have x equals 0. Really plus or minus 0, but that really doesn't do anything here. So the vertical asymptote is x equals 0, just like in the what? Just like in the parent function. Very nice. We're all geniuses today. So in order to find the horizontal asymptote, you want to look at the degree. So the degree of the numerator is what? 3. And the denominator? 2. And so that means that we've got the second rule of the horizontal asymptote section of our notes. So bigger power, whoops, bigger power on top, which means we're kind of invoking that second rule of horizontal asymptotes, which is if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Good. So what are we going to put here? None. So we need to check to see if there is a slant asymptote. Remember, the slant asymptote happens when the numerator's power is just 1 more than the denominator's. So do I have that here? Yes, I do have a slant asymptote, which means I actually need to divide. When I divide by a monomial, do I need to do long division? No. I need to take this monomial and I need to make it the denominator of each of these, right? So it's kind of like I do this. So x cubed over x squared, and then I do this. Plus 1 over x squared. This was on your test from earlier in the week. Yeah, that was on your test. So when you simplify this, what does x cubed over x squared become? X. Can you simplify this at all? No. If you were to have done long division, this would have been like your remainder. And remember I told you that we're kind of ignoring remainders right now. So the equation of the slant asymptote is y equals x. That's it. Because that's what you got when you divided the numerator by the denominator, ignoring that remainder. Which, by the way, this is kind of a special function. This is the what? Do you remember what this is? Y equals x. And that's not cubic because it doesn't have a cube. It has an exponent of 1, so it's a linear what? Linear parent function. There we go. So the linear parent function is the slant asymptote. That's kind of nice. Okay. Okay. So we move to number 8 because number 8's similar to what we just did. And I know that you've all had a chance to look at number 8. If I were to factor the problem, do I need to factor the denominator? No, it's as factored as it can get. But the numerator can be broken up into x what? Minus 2 and x plus 2. No, plus 1. There we go. So is there a common factor? Hush. Is there a common factor on the top and the bottom? No. So is there a hole? No, there are no holes in this rational function. Hey, stop. There are no holes in this rational function, so that means that this is just kind of the simplified version of the function. In order to find the vertical asymptote, raise your hand if you can tell me what to do. Yes, ma'am? Set the denominator equal to 0. So if I set the denominator equal to 0, there's a vertical asymptote where x equals what? 1. Excellent. For the horizontal asymptote, I need to look at the what? The degrees, right? The powers, the highest powers of the numerator and the denominator. Raise your hand if you can make an observation about the powers or the degrees in this problem. Yes, sir. To what? The top is bigger than the bottom by how much? By 1, right? So if we have a degree on top that's bigger than the degree on the bottom, so top is bigger, then that implies that there is what? No horizontal asymptote, so there's none. And because the top degree is bigger by 1, that means we're looking at a slant asymptote situation. So y equals something is going to be a slant asymptote. How do I find a slant asymptote? Raise your hand if you can tell me how I find it. Yes, sir. Long division, right? So I actually need to divide. I'm not going to divide what's already factored, because that's silly. I'm going to actually divide the problem, the original problem. So I've got x minus 1, and it's going into x squared minus x minus 2, right? So long division, x squared divided by x is x. X times x is x squared. X times negative 1 is negative x. Draw the line. Change both signs. These cancel. So do these. There's no x's here, but I do need to bring down minus 2. How many times does x go into 0x? 0 times. 0 times x is 0x. 0 times negative 1 is 0. Draw the line. What? Change both signs. Nothing happens here. This is negative 2. It's my remainder. So minus 2 over x minus 1. Do I really need to look at the remainder? No, so it's just x. So the slant asymptote is y equals x, which happens to, again, be the linear parent function. Yes? Did anybody try synthetic division? Do you get the same thing? Yeah, do you like doing the synthetic division more? Mm-hmm. So if I do that, 1 times 1 is 1. This is 0. This is 0. So this is x plus 0 minus 2 over x minus 1. So did it still work? Yeah, it still works. Can you do synthetic division? Yes. Which one do you need more practice with? Perhaps if you need more practice with long division, maybe you should do it here. Check it with synthetic if you want to, but I do want you to make sure you get the practice in with this. Okay? All right, let's see where we're going from here. We did 1 and 2. We haven't done 5. And we haven't done 6 and 7. So we will do one more. Which one would you like to do? 5, 6, or 7? 6? 5? 6, 5, 4. Raise your hand if you want 5. We're voting. 1, 2, probably not going to win. Raise your hand if you want 6. 1, 2, 3, 4, 5, 6, 7, 8. Raise your hand if you want 7. 6 wins. No, no bribery. Sorry. All right. Number 6. For number 6, can you factor the numerator and denominator? Yes, please do, because you want to check for what? Holes. Perhaps there's another one that has a hole that we can do. Okay. Are there any common factors on top and bottom you can cancel out? No. So are there any holes in this rational function? No. So I'm going to proceed as I typically would to find the vertical asymptote. I would set the denominator equal to 0. I get x equals negative 3, and I get x equals negative 1. So those are my vertical asymptote values. What did you say? There is a horizontal asymptote because the degrees in the numerator and denominator are what? They're equal. They are both 2. Right? So same degree means that for my horizontal asymptote, I need to look at the what? Coefficients, right? So 1 over 1 equals 1. So my horizontal asymptote is at y equals 1. And because there's a horizontal asymptote, there is no slant asymptote. Very nice. Of course, yes, we can do 5. That did have the second most votes. I don't know if anybody voted for 7. So let me go find 5. May I move this from the screen? Okay. Let's go find, yes. Okay. So how did you recognize that 5 had a hole? The difference of squares will provide on the denominator x plus 4 and x minus 4. So you can cancel out those x minus 4s. So go ahead and factor. Me too. Okay. Okay. So on number 5, we decided that we could cancel out the x minus 4, correct? Which leaves what? X plus 4 on the bottom. Good. 1 over x plus 4. Okay, so this is my new simplified function. There is a hole where x equals what? 4. Good. Where x minus 4 is 0. So where x equals 4. There is a hole there. Okay. When I find my vertical asymptote, what do I need to do with the denominator? Set it equal to 0. And this is my new denominator, right? So I'm going to set x plus 4 equal to 0. My vertical asymptote is at x equals negative 4. Okay. When I look at my original function to determine a horizontal asymptote, the degree on top is what? 1. The degree on bottom is 2, so it's smaller on the top, bigger on the bottom. What does that imply?
There's a slant.
There we go. Let's go back and look. If it's smaller on the top, bigger on the bottom, that means that what? Y equals 0 is the horizontal asymptote. So I'm going to go back and put y equals 0. So smaller on top equals the horizontal asymptote is 0. Is there a slant asymptote? There's not, because why? Because the numerator degree is not bigger than the denominator degree. So there is none. So in the situation, quiet please, in the situation where you would have a hole, you want to make sure that you find the vertical asymptote based on the simplified function, and you want to make sure that you really pay attention to that horizontal asymptote. Okay? Are there any last questions?